Alright, in this video, we'll be treating more on power rule by monomial function. And I'll be telling you guys more about monomial function. First of all, before we apply the power rule, you can either call it power rule or general method of differentiation. Please take notes. Okay, now let's try to know what is monomial function first. Now, if I have a function like this, y is equal to as raised of n. So if definitely I have one digit, this a here stands in place of one digit, a letter, and a power. Please take note. One digit, a letter, and a power. We call this function or expression monomial function. So how do we now differentiate this guy here? Now, for us to differentiate, first of all, we have to know how we differentiate with respect to. Please take note. Now, how do we differentiate with respect to? If I have something like this, maybe I have y is equal to 2s squared, like this. At this point, to differentiate here, I will differentiate with respect to s. Why? Because in terms of differentiation, we define derivative as the ratio of the dependent variable to independent variable. Now, what is dependent here? The letter that acts as subject is the dependent, while the letter that acts that is not the subject here is what? Independent. So it's going to be dy over what? ds in terms of this guy here. But if I have this to be, maybe I have y is equal to 2t raised to 3. Now to evaluate or to solve for our derivative here, to express our derivative here is going to be dy over what? dt. Why? Because the dependent is y, independent is what? t. And I told you guys that derivative is always expressed in the ratio of dependent over what? Independent. So this will be dy over what? dt. So at this point here, to express the derivative here is going to be dy over what? ds. And how do I perform this? I will take the power here down to the base here and subtract 1 from it. This will be equal to n times as raised to what? N minus 1. Please take note. So for all monomial function, that is any function or equation that have only one digit, letter, and power here, this is the format we always use to differentiate that. So let's solve some questions here. Okay, let's solve these questions here. That's let's take these examples. Now we say find y prime. Now y prime in terms of derivative is the same as dy ds. Please take notes. Given that y is equal to 3s raised to minus 5. And I say number 2, if y is equal to square root of s, find dy ds. Question 5, y is equal to 5 over s. Find the slope. So now let's try to solve these questions here. Okay, first of all, I told you guys whenever we have a monomial function, this guy here is a monomial function. That means it consists of only one digit here. It has letter and a power to it. So the format to solve this guy here, I told you guys that y equal to as raised to n. That means our dy over ds will be equal to, take this guy down to the base, this will be n times a s raised to n minus 1. So this is the point here. So now let's try to differentiate this guy here. I have this to be y to be equal to 3s raised to minus 5. Now let's find dy ds here. So our dy over ds will be equal to plus. Let's take this guy here, the same thing we did here. Let's take this power here down to the base and subtract 1 from it. It's going to be minus 5 times 3 of s raised to minus 5 minus 1. Now at this point we can now evaluate. Minus 5 times 3 will give us minus 15 of s. Now minus 5 minus 1, what is the answer? Minus 6. This is the answer to this guy here. Okay, let's evaluate this one here. Number 2, it said if y is equal to square root of s, find dy ds. Y to be equal to square root of s. Now, how do we set up this expression to be in terms of polynomial? Remember, I have one number here, I have a letter here. That means I can set up here to be polynomial. In terms of our indices, we know that if I have this to be square root of a in terms of indices, it is same thing as a raised of what? 1 over 2. That means square root is the same thing as what? 1 over 2. Please take note. So this is the same thing as s raised of 1 over 2. So at this point here, we can easily differentiate this guy here since we have actually replaced this in terms of monomial. 1 digit power to it, and there is a letter. So this will be our dy over dx will be equal to, take this power here, remember, down to the base. This will be 1 over 2 of s, that is s here. Subtract 1 from it will be 1 over 2 minus 1. Please take note. So let's try to evaluate this power here. Please take note of this. Evaluating this power here just like a fraction. And this is the simplest way to do that. Please take note. This is the simplest way to do that. If I have 1 over 2 minus 1 like this, and I want to use my short way to solve this fraction here, I'll set up this guy here to be in terms of fraction. Also, this is the same thing as over 1 here. So what is short way here? Times this denominator to the opposite. This will be 1 times 1 times this denominator here to the opposite. This is 2 times 1 times both denominator here. This is going to be 1. This time this will be 1. If there's minus, you put minus. If there's plus, you put plus. Please take note. 2 times 1, what is the answer? 2 over what? Times both denominator, what's the answer? 2. This will be minus 1 over what? 2. So this is how we evaluate our two fractions. We only use this method if definitely I have this to be in what? Two fractions. Please take note. Okay, now let's try to apply the same thing here. So this is going to be our dy over dx will be equal to 1 over 2 of s raised of minus 1 over 2. Please take note. This is the answer, of course, but we can think further this to get the right expression. This is the same thing as, please take note, and 1 times s will give us s, please take note of this, raised of what? Minus 1 over 2 over what? 2. Now making this guy here to be in terms of positive, making this guy to be in terms of positive is the same thing as, I will take this guy down to the base here, sorry, down to the denominator here. Please take note. So I want to make this minus to be positive. If I have this to be 1 over s, in indices, is the same thing as what? S raised of what? Minus 1. So it means anytime you are taking anything from denominator to numerator, the power will change. The sign of the power will change. So the same thing here. Anytime you are taking anything from numerator to denominator, the sign of the power will also change. So I want to take this guy here from numerator to denominator. This will be 1 over 2 of s raised of what? 1 over 2. Please take note. So finally, I can write this to be our dy dx here. Listen, please. Let's solve the last one here. Number 3. They say y is equal to 5 over s. Find the slope. Now listen. In terms of calculus, there are some words that represent dy dx or derivative. Whenever you hear about slope, tangent, and gradient, please take note. Whenever you hear about these guys here, that is slope, tangent, gradient, they all represent dy dx. So we are given y equal to 5 over s. Find the slope. So it means that we should find dy dx here. Please take note. So I have this to be y to be equal to 5 over s. Please take note of this. So this guy here can be represented in a linear form. How? Because I know that if I have 1 over s is the same as s raised to 4 minus 1. That means I can take this from the down to up. Please take note. So making this here to look like this guy here to be linear, this is the same thing as 5 of s raised to 4 minus 1. Please take note. We only do this if you have a single numerator and a single denominator. Please take note. So whenever you have a single numerator and a single denominator, it can be expressed in a linear form. So at this point here, we can now differentiate this guy here. So let's differentiate this guy here. Our dy over dx will be equal to, now take this power down to the base here, subtract 1 from it. This is going to be 5 times minus 1. Please take note. What again? Of s raised of what? Minus 1 minus 1. You can take this guy here first. and times this guy. So this is going to be equal to minus 5 of s raised power of what? Minus 2. Please take note. So this is our answer.